In this final equation video, we're going to take a look at some weird possibilities. So we're doing the last four problems here, numbers 55 to 58. And we're going to have some of the same stuff we've seen before, where we might have some distribution, like in 57 and 58. We definitely have the variable on both sides of the equation in all four problems. In number 55, we've got some like terms to combine on the right-hand side. So this is going to be a lot of review, but something unique is going to happen. So let me just show you here real fast in number 55. Look at that right side. See that negative 5n plus n. Realize we do need to combine them. And negative 5n plus n is negative 4n. Now some of you may already sense that something odd is going on here when you read this statement. Negative 6 minus 4n equals negative 6 minus 4n. That sounds reasonable. Let me take this a step further. If we wanted to get our n's on the same side, we normally say which is smaller. Well, they're exactly the same, so technically neither one is bigger, neither one is smaller. But if I wanted to put them together, I would add 4n to both sides. But if I do that, negative 4n plus 4n cancels. Negative 4n plus 4n cancels. I'm left with negative 6 equals negative 6. This is not wrong. We have not done anything incorrectly. It is possible, not a common occurrence, but it is possible for variables to completely eliminate as you solve a problem. When that happens, you're going to be left with a statement. Here the statement is that negative 6 is equal to negative 6. And you have to decide, is that statement true or false? This statement is obviously true. Negative 6 is equal to itself. When that happens, the reality of the situation is that it doesn't matter what you plug in for x. Any and every number you could think of would work. So how can we represent that idea? Mathematicians have a symbol for it. Take a look at that. It's an R, but the top of the R is extended back to the left some more, and another vertical bar is dropped down from it. And this is a mathematical symbol that stands for the idea of all real numbers. Yes, the fact that we say there are real numbers implies there are imaginary numbers, and there are, and we won't deal with them this year, or even next year in Algebra 1. You will deal without imaginary numbers in Algebra 2. Now, that's one possibility. We solve a problem, our variables disappear, and the statement is true, meaning no matter what we tried to use for x, everything would work, all real numbers. What's the other possibility? Well, we solve a problem and our variables disappear, and what's left isn't true. Let's look at 56. Now there's no simplifying to do. The left-hand side is clean, the right-hand side is clean. So if we were to say, okay, we need to get the x's together. They're positive 7x's, so we would subtract them to eliminate. That gives me negative 1 on the left-hand side, and 7x minus 7x is 0 on the right-hand side. And we shouldn't be afraid of 0. When 0 shows up, that's fine, we just got to write it down. So another instance, our variable has disappeared, but this time we have a statement that is not true. Negative 1 does not equal 0. So how do we illustrate this idea? What this means is that no matter what you would try to plug in for x, not a single thing could actually work. If something could work, we would have gotten a solution. If everything worked, we would have gotten a true statement. Because we got a false statement, absolutely nothing will work. So do we have a symbol for this? Of course we do. We're mathematicians. We have symbols for darn near anything. The symbol for nothing works looks like a 0 with a slash through it. This symbol is what we call the empty set or the null set, those are fancy names for it, most mathematicians recognize it as meaning there's no solution to the problem. So I'm not introducing any new math to you today. How we're solving these problems hasn't changed. It's just that sometimes they won't give you a solution. Sometimes you'll get a statement that is either true or false. The last two examples, which you can pause the video and attempt, should result in something similar, but let's just run them out and check. In number 57, I see distribution, so I'm going to do that first. And my right-hand side has like terms, so I'm going to combine them. Now when I go to put my x's together, when I add 5x to both sides, they cancel out completely, leaving me with the statement that 2 is equal to 2. That is a true statement. So number 57 has all real numbers as the solution set. And on the final problem, again, I see distribution. So let me take care of the distribution. I have like terms on the left-hand side. N plus 3n is 4n, and I apologize, that's the right-hand side, not the left-hand side. Now when I try to take care of my variables, they cancel out again, but I'm left with the statement that 31 equals 24. We know that 31 is not equal to 24, so number 58 has no solution.